Very enlightening. Questions? We'll take some questions to Bertrand now. Who would like to hop up?
Nils Roland with ProTeam Statoil in Norway. Why didn't you include flow in and flow out?
Okay, what I've done here is to take the 4 fundamental signals that over 40 years of recording we can hope to have. Actually, we don't even have those 4. There are many jobs where we don't have the 4 and we have to deal with even more sparse data. But there are essentially the 4 fundamentals. What we then need to do in terms of automation is to combine those with all the available information, all the other available information, including surface and downhole. However, we cannot go there before we've solved that problem, which is a minimalist problem. Actually, it's not even the minimalist problem, and there is another part of investigation, which is how to deal with when one of the 4, 2 of the 4 are missing, which is very interesting and important problem. But we can take as a basis for our industry those 4. And then we move up from there with all the other signals which are available for any particular job. So the answer is definitely, if you have them, help get the first result that you need to get, which is when are we in slips. That's what we want to get. So anything which helps you do that will help in building up automation, for sure. Flow in, flow out, and a lot of other signals.
Are you going to combine this with heave on a floating rig? The heave of the pipe in and out of the valve, is that the next phase?
Yeah, of course. And I want also to get information whether I am actually, I really want to get the information on the bottom, especially for, for angles and stuff like that. So, absolutely. Absolutely. I mean, fully.
You have to check that you get your flow in and out, so you see if you get an influx, and also you need to see the surge. So,
no, I agree.
That's the next phase, I believe.
Yeah,
so that's the basics you have done now.
Yeah, no, I agree. I mean, I hope you see that we can build a lot on top of that. So, but I fully agree.
Someone else like to pose a question to Bertrand?
Tim Morning with Marine Cybernetics. What parallels exist or do you see between what you're trying to do here and what may have already been accomplished in autopilots and avionics and fly-by-wire?
There are many ways to answer that. At the there are many technologies which pop up to mind. And for example, you have self-organizing maps. You have a trajectory control. You have inflection. The points which is used in aviation. And in fact, it turns out that all these algorithms have been considered here. Here I will make a personal observation of it. Having been involved in those things, and with my experience, there are a lot of publications in that field too. And what we see is that we have to revert to the physics of it. We have to the signal processing is very much associated with the physics of drilling, and not with the physics of avionics. And that would be really my fundamental answer. Is that this is physics. Each time you try to understand what the signal, you need to get back to try to understand what was the underlying physical phenomenon, and that drives, if you want, what you're going to apply. And if you try to apply, for example, and a good example that we've tried to apply is the change point, used in aviation, and they are very good, but here in particular, they break in terms of the fractal nature of the signal. That would be one example, if you want. So my answer would be at this point is that we have to respect the physics, and the physics is the physics of drilling.
The brain is pretty good at accepting incomplete information and our partial information. So we have a hook load with 100,000 pounds on it. It's fairly easy to know if we're in slips, but if we have 3 singles of heavyweight, we don't know. But the driller can make adjustments as we go. Do you see these systems beginning to deal with this amount of uncertainty, correct that uncertainty as more data is available? And how does that fit together in the human brain and the computer?
So the answer is yes. And the answer is no to your view of it that you've published. Is that you published, if you've read that, you published that you saw that we could build an ontology of things that can go wrong. I don't believe that. I think we can build a lot and try to understand a lot of the things that can go wrong, but not everything, and we need to have systems which need to be able to recover in very uncertain situations. Which means that when the system, and by the way, these stochastic grammars are very good at that. If you don't, then we go into the techniques of it, Viterbi and everything. But what happens is that, we try to understand what's going on in context, So we look at everything which has happened, and we say, that's what's most likely. But very often things break down. We cannot reach a conclusion. And at that point, we cannot say, let's stop all the operations. So we need to have systems which can recover, saying, well, we really don't know, but let's see really what we were thinking before and if we were on the wrong path. And come back and always recover even from the most uncertain situation without even knowing or deciding what those uncertain situations were. And that's why I don't think we can build ontologies of errors and uncertainty in their totality. We can do that. We have to do that to the biggest extent. But then we need to have systems which are capable of doing what the human brain says, I'm lost, but I'm going to find a way out of this jungle. And that does that. That does that because it is based on, if you look at the neuroscience today, all the models are derivatives of Bayesian statistics. So there are various forms of derivatives. All the forms which can work here are very complex. They are hierarchical, they have a lot of components, but mathematically they are equivalent to the technologies used there. And whether that technology or another, we at least the consensus today is that this is the kind of computation we have to make. So the answer to that is to say, to your question is to say, yes, I think we can do a lot. But we need to be aware of doing it that our systems themselves have to have the power of recovering from bad situations.